All right, our final example for increasing and decreasing intervals looks to be pretty fun. So we're given a graph of f prime of x, the derivative of f is shown below, and then things get really fun. G of x is equal to f of x squared minus 1. So we have this composition of functions, and we're being asked to figure out when this g is either increasing or decreasing. I love it. All right, well, first things first, we need to figure out what g prime is, right? G of x increasing or decreasing will be determined when g of x is either greater than or equal to 0 or less than or equal to 0. So whether we're finding critical values or intervals of increasing, decreasing, let's go figure out what our derivative is. And we need to recognize that if our original g of x is equal to this nastiness, we have to use our chain rule. So when we take our first derivative of the outside function, leave that inside the same, times the derivative of our inside function, right? So that's what we're going to get. So we want to know, questions. When is this, right, if we're finding our critical values, when is this either equal to 0 or undefined? And technically, f prime of x, as shown off to the side, is a polynomial, right? It looks pretty quadratic, looks continuous, and so is 2x. So polynomial times a polynomial is just another polynomial. We don't have to worry about undefined. We need to think about when this thing is equal to 0. So we have two things multiplied together, which means we're in 0 factor land, right? If two things are multiplied together to equal 0, that means one of them is either equal to 0. So either f prime of x squared minus 1 is equal to 0, or 2x is equal to 0. Well, that bottom one's super easy to solve. Can divide that through by 2, and I get x is equal to 0. And then my f prime, well, ignoring the inside function for a second, f prime was never equal to 0, right? It never crossed the x-axis. Okay, so I think that would mean I only have one critical value. F prime never equals 0, and 2x equals 0 when x is equal to 0. So we've got our critical value, just the one. That's it. I'm boxing it like we're done, but we're not done. We're not done at all. So let's put in our 0, and then let's use a test point to see what happens. So we'll go ahead and test with, say, -1. I'll put -1 below, so we're being consistent. So at -1, let's see what happens with our g prime. G prime of -1 is equal to f prime of -1 squared minus 1 times 2 times the -1. So we have f prime of 1 minus 1, 0, times 2 times the -1. And we go, okay, f prime of 0, well, this is f prime at 0. Looks like it's 2.5. So 2.5 times a -2 is a -5. That doesn't matter the value of it. What matters is that it's negative, right? So I could say g is decreasing on this interval. And then I go to the other side and say, okay, well, let me test a point. And maybe I start recognizing something clever now. This is going to be the same thing on the other side, right? Because instead of -1, I can change this to +1. Then we have a +1 there. We have a +1 here. That's still 0. So we'll end up with a +5. So this section is positive. And if we think about it in terms of our factors, right? In terms if we made like a table for this plus minuses like you probably did back in rational and polynomial inequality land, our f prime was always above the x-axis. So f prime was always positive. This didn't tell me anything about whether g prime was positive or negative. It didn't give me any zeros. F prime was kind of useless. Not useless, but like didn't matter for much of anything. It did matter because it gave me the 2x, and 2x is the piece that mattered. 2x is our line that goes from positive or negative to positive, right? It has a positive slope. So here's where we're at. We have our intervals of increasing. That's happening from 0 to infinity. And we have an interval of decreasing, which is happening from, -infinity. up to that 0. So there you go. That's example 10. I love it. It brings in our old derivative rules with our graphs, with our actual algebraic stuff. Like, this was a beautiful question. I wish our f prime actually had 2 intersections or an intersection, because it would have made this much more exciting.